Okay, today we will go over some old test one, and I will not go over everything. I will just do number 1 to number 9 because that is what being covered in my lesson 1 to lesson 5, as I remember. Okay, now before you really watch this, or if you watch this now and you feel like you kind of like a bit lost here and there, make sure you go back to those lecture videos. Okay, and actually let me show you more. I think if you go to my announcement boards on announcement number 3, you can see that I went over the old tests here. I went over some old tests here. Okay, some old quiz and some old tests. Okay, it's in the announcement board. Okay, let's start going over this spring 8. Today I will go over spring 18 and fall 18 math 227 test 1. The file is in your discussion board for today, and actually last time also from Tuesday. What I plan to do is I will work on the first page first. Okay, and then once we're done with the first page, we will go on to fall 18 math 227 test 1, also the first page. Okay, do it now. Let me insert that now. Give me a second. Okay, so this is what fall 18 test look like. Okay, so I will do page 1 for spring 18 and then come back to page 2. Oh, hold on. Are they the same? Oh, shoot.
I think, yeah, Thomas, I think they're the same. I kind of was looking.
Are they exactly the same?
I think so.
Oh, wow. That's really nice of me, Thomas.
I was kind of noticing that when I started working.
Oh, okay. Then I will choose another file then. I'll choose another file later on. I forgot which ones I already did. I have video on. But yes, let's choose another one later on. Okay, let's work on this first then. Let's work on this first. Let's start. The following are test 1 scores of my elementary algebra classes this semester. That's from spring 18. Consider this as a sample. Okay, that's a sample. So what is the sample size? Each row, each column here is 10. So 10, 20, 30, 40, 50, 60, 74. So the position of the median will be 74 plus 1 over 2 equals to 37.5. Right? Now that's the position. So you write it aside. Don't write it next to the median. Okay. Now when you write the median, then you say, oh, it's supposed to be data number between data number 37 and data number 38. Is it right? So what is data number 37? 10, 20, 30, 1, 2, 3, 4, 5, 6. This is data number 37. And this is data number 38. Am I okay?
Yeah.
Yes.
So the median will be in between those two numbers, right? So you need to write it this way. 45 plus 45 over 2 equals to 45. Even though you and I know the average of two same numbers will be the same number, but you still need to write it this way. This is the way we show that the median is actually between two numbers by working it out this way. Okay. If you just write 45, for example, it means you are referring to this 45 as one of the number, either this one or that one. But in this case, that's not what we want to say. We want to say it's between these two 45s, right? So you have to write the one I mark in yellow here. Okay. Now, how about the mode?
32.
32 happens 3 times. Is there anything else?
I don't think so.
Yeah, just 32, huh? Okay, 32. Okay, now, how about the first quartile? Now, notice that the median is in between these two numbers, right? So the lower half will be everything up to the data right before the median, including that 45. Now, how many data? What is the size of the lower half? The size of the lower half is 37 data, right? Plus 1 divided by 2, that's 19. So we need to look for data number 19. Data number 19 is 10 here. This is 20, right? So this is 19. Okay. Now you can count it this way. Data number 19 from the front. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's one way, right? Which is what we usually do. But if you think about it, actually, this data must be in the middle of the lower half. So even if you count it from the largest of that lower half, from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 19. You still hit the same number. Okay. So the first quartile is 24. How about the third quartile? It'll be the same position though. It'll be the same position. Data number 19 in the upper half. Data number 19 in the upper half. 1, 2, 3 plus 10, that's 30, 40, 50, 13, 14, 15, 16, 17, 18, 19. Now, let's confirm that. Let me count it from, count it backward. 1, 2, 3, 4 plus 10, that's 14, 15, 16, 17, 18, 19. Is it okay?
Yes.
So that's the third quartile. We are done. Now, how about the range? The range is equal to the largest data minus the smallest data. So the range is 99. Number 6, create a frequency distribution with 5 classes from the data above. We need to create a frequency distribution with 5 classes. Now, we need to first find the class width. The class width, W, is equals to the round up the ceiling of the range over the number of classes. Now, I will always tell you how many classes you need to create. Okay, usually 4, 5, or 6. Usually 4, 5, or 6. In practice, there's actually a formula. There are 2 very well-known formulas to tell us the number of classes, but that's beyond the scope of this level. So I will tell you how many classes. Okay, and then 99 divided by 5 is 19.8, I believe. Okay, which if we round up, that is equal to 20. That's the class width. Now then, when you construct your frequency distribution, this is the scores, or you can also call that the X, and this is the frequency. Now, we will have 5 classes, right? We'll have 5 classes. Let me give like, so the first class, the second, the third, the fourth, the fifth. We should have 5 classes. Now, in the first class, we will start from the minimum data. We will start from the minimum data. Okay, we'll start from the minimum data. And then from there, we use the class width to add to get the next lower class limit. So this is where the class width come into play. You add 20, that's how you get 0 plus 20 is 20. And you add 20 again, 20. Now remember, class width is defined to be the difference between consecutive lower class limits. Okay, the difference between consecutive lower class limits. So you add 20 and then you add 20 again, you add 20 again until you have 5 classes. Now, because you round it to the nearest ones, the nearest unit, right, 20, then we subtract that lower class limit by 1 to give us this upper class limit. From this 20 here, subtract by 1, give you that upper class limit of the previous class. Now then, from here you go on, you keep on adding 20 again. You add 20, you add 20, you add 20. From 59, you add 20. From 79, you add 20. Now, it just happened in this case that the upper class limit of the highest class is the same to the maximum value. That is not usually the case. It is possible that this upper class limit of the highest class here is, let's say, 100 or 102. That's okay. Okay, just make sure that you keep on adding the class width from here. You add the class width, 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 like that. Are you with me?
Yes.
Okay.
Yes.
Because you will see that your test 1, especially the first 9 questions, those are procedure. So I want to make sure that you are good with the procedure. Okay, it's supposed to be like less thinking, more practice case. Now then, once we're done with the scores, then we do the tally, see the frequency for the first class, from 0 to 19, how many? And I purposely make it in each column is 10 so that it's easier for you to count it. It's already 10. Right, 11, 12, 13, 14, 15. So this is 15. I'm sorry. Oh yeah, up to 19 is there, right? Yeah. And then from 20 to 39. From 20 to 39. Right? How many are there?
17.
17. And then from 40 to 59.
19.
19. And then from 60 to 79.
14.
14. And then from 80 to 99.
9.
There are 9 of them. Now, then once you're done with this, make sure you add them. Okay, make sure you add them and add them separately. Like you use your calculator, 15 plus 17 plus 19 plus 14 plus 9. What's that?
74.
74. Then you check, do you have 74 data here? Okay, what we don't want to happen is this: you happen to double count something or you miss something. You see, so we know it's 74 here, right? Do not assume that, oh, you know what, all my numbers here, do not assume that all your numbers here must be correct. You know, because it is possible. I have seen that those cases, like that person actually missing one row, but that person still writes 74. You know, and one of the effect that you will see later on is your variance will be negative. It could be, right? You know, the variance should not be negative, but if that's what you do, then you will see those kind of error. Okay, now then let's go on with this. Number 7. Number 7 is, I consider my number 7 actually a bonus question. I hope you know why. It's like one of the easiest question in all my tests. So we will construct, we will copy that frequency distribution in number 6. Okay, so we have the scores. And then the frequency, which I will just shorten as an F. And then extend it to have lower class limit. And then upper class limit, lower class boundary, upper class boundary, and then relative frequency. It will be nice if during the test you can prepare some ruler. Yeah. Okay, and yeah, basically try to make it nice. Then I will copy the first 2 columns. I will copy from what I had there. And then there were 15, 17, 19, 14, 9, 74. Don't forget to always add the frequency. Okay, it looks like P. Now, what is the lower class limit here? Anybody can help me with this?
0.
And then,
20,
and then,
40,
and then,
60,
and then.
80.
Now, this one column here is your 1 point. Easy, right? Now, how about the
Easy.
up? It's supposed to be easy peasy. How about upper class limit?
19,
And then,
39,
and then,
59,
and then,
79,
and
99.
then. Okay, good. Now, for lower class limit, upper class limit, we need to do from the second class first. Now, the reason is because the upper class boundary and lower class boundary actually in between the consecutive upper class limit and the lower class limit. So the midpoint of these 2 here will give you these numbers. These 2 numbers must be the same. Okay, now what's the midpoint?
19.5.
19.5, that's right. So it will be 19.5 here. And this is also 19.5. Okay, and how about the next one here?
39.5.
39.5. This must be 39.5 also.
59.5.
59.5. This is 59.5. 79.5. This is 79.5. And therefore this is should be 99.5.
Yeah.
And this one will be
Negative 0.5.
negative 0.5. Don't forget the leading
0.5.
zero.
Yeah.
Okay.
Yeah.
Now, then the relative frequency, usually, I said this in my lecture, I said it in my supplemental video, I said it again. Usually, in practice, relative frequency is written in percentage, usually. If not, then in decimal. Now, in my class, I allow you to write it in fraction. Okay, the frequency of this class, that class divided by the total frequency. In this case, the sample size. So the second class, the relative frequency is 17/74. The third class is, the relative frequency of the third class is 19/74, 14/74, and 9/74. Now the total should be 1. Okay, now most students actually get this part correct. Okay, except if they lose any point, they tend to lose it. Can you guess where they lose the point?
They don't write that it equals 1.
Yeah, they lose the point here and here. That's the tendency. I mean, these students, they know what to do, but they forget to add. When it comes to frequency, you have to add. Okay, if you have relative frequency or frequency distribution, you always need to add the frequency. Okay, and also relative frequency. Now, adding this here is to confirm that everybody is accounted for, nothing more, nothing less. Okay, let me see if I have other tests that I can ask you to do. You know what?
Thomas,
really-
I thought we were gonna go to 8 or till 9 question.
Yes, yes, but let me do that page 1 first, and then
Okay.
I want to see if there's any. Should I try 415? No, I don't have test 1 415 in my computer here. 416. I have it, but not in PDF. How about Spring 15? Don't have it on my computer. Spring 16, I do. Oh, but not in PDF. Oh, let me do it. Let me make it into PDF first. Give me a second. I really want to make sure that you can do it yourself, you know, because you don't want to waste such an easy question. Oh, okay. Now, of course, if you don't practice, it becomes hard, right? But on the other hand, if you practice, and then it becomes an easy question, and I don't want you to miss it. My test 1 is the easiest test, and usually that's also the highest test score students have. You know, that's why I want to make sure that you really get it. That's for you, not for me. Now let me insert this page there. Give me a second, okay? Insert, that's from Spring 16. Okay, let me ask you to do this problem. I will put on the screen the data, but you can see question number 1 to number 8 are exactly the same question. So I will enlarge this even further. Okay, maybe you want to copy down this data, or you know what? No, you don't need to copy it down. I will post the file on our discussion board. Okay, but start working with that number 1 to number 7. Do you think you can do that?
Yes.
Yeah.
Okay. How many minutes do you think you need? Will 15 minutes be reasonable?
Yes.
I think so.
Okay,
Yeah.
let's do 15 minutes. But if you are not done in 15 minutes, don't worry about it. I will just work on that. Okay. Yeah. Let me ask you to do this then. 15 minutes. Right now it's 8 o'clock. I will start working on this at 8:15, 8:16 maybe. Okay, work on that, please. Sonia, do you mind to go to breakout room?
Did anyone take a screenshot of the numbers?
No, but if you go to the discussion boards, he
Did he-
posted it up on there. Yeah.
Oh, awesome. Thank you.
Mhm.
Oh, I'm sorry. Did the screen suddenly not visible earlier?
Yeah, once you go to a breakout room, it stops sharing, but we were just saying that you posted it, so we went on there.
Oh, okay, okay. Thank you.
Professor, can you scroll down a little bit so we could see the next question?
Okay, give me a second. The next question is the same to the previous one.
Got it. Thank you.
Okay.
Mimi, Mimi.
Do you need more time?
No.
You're good? The time for you to do my problem in my quiz or in my test, the quiz, we don't really worry, right? But in your test, when you practice at home, you see the number of points for that question. Like this one here, 2 points means it should take you less than 2 minutes to do this problem. The number of points, let's say one here means it should take you less than 1 minute to do it. Now, that way, when you practice at home, you can manage your time better. You know, sometimes when we take the test, we keep on feeling that, well, you know what, I don't have enough time. I don't have enough time, right? Now, at home, you practice your time also. Okay, like number 6, 7 means it should take you less than 7 minutes to do that problem. Does it make sense? That's the number of points for that question, but that's also a good hint of number of minutes you should take when you do that problem. Okay, this is a population, so let's start. So far, we don't really need the fact that it is population to work on this problem, though. It only appears in the second page. Okay, let's start. So the sample population size here is 53. So the median is position at 53 plus 1 over 2. That's the 27th data. Data number 27 is 58. Right?
Yes.
Yeah.
Okay, now then, what is the mode? I see 86 happened 3 times.
86, yeah.
Is it the only one?
I think so.
It could be two. It could be 2 modes though. Okay, 86. Okay, then the first quartile. 27th is the 27th data is the median. So the lower half is everything to the left of that or everything less than that. So up to here. How many data are there?
26.
26.
26, so 26 plus 1 divided by 2 is 13.5, right? So we look for data number 13th and data number 14th. Data number 13th is 38, data number 14 is 39. So this is 38 plus 39 over 2, that's 38.5. Data number 13 from the top is 79. Data number 14 from the top also 79. So 79 plus 79 over 2 equals to 79. Okay. So every time you get the median or the first quartile, the third quartile between 2 numbers, you have to write this before you give me the answer. Okay, keep that in mind. Huh? What happened? Now then the range will be 104 minus 8, that will be 96. Now then construct a frequency distribution with 5 classes from the data above. So the class width will be 96 over 5. We always round up. That is 19.2. But when we round up, what will that be?
20.
Also 20. Okay, we don't do regular rounding, we round up, we always round up. Now, what happens if you round down? In this case, if you round it to 19, then you will see that the highest score will not be included in the highest class. That's why. Scores, frequency. Yeah, if you want to save your time, just write X and F. I will be good enough. So the lowest score is what? Is 8. Now then plus the class width, that's 28, plus class width 20 becomes 48, becomes 68, becomes 88. And this is 27, 47, 67, 87. And what is the last one?
107.
107 or 104?
107.
107, that's right. So we keep on adding the class width, okay? But Thomas, the maximum data is 104, that's right. But doesn't matter, we still put the class width. You add the class width, add the class width, add the class width. Okay. Now you may wonder about, but Thomas, the class width is 20. But if I see here, like let's say we pick this class here. When I see here, the class width seems to be only 19. How do you get that 19? Because 47. Because 47 minus 28 is 19. So the class width only 19. Well, that's if that's how you count it. But the thing is, that's not how you count actually. Okay. Now let me explain it this way. I believe I explained it in my recording, but I also want to mention it here. Okay. If you have houses, okay, number 1, number 2, number 3, number 4, number 5. How many houses here?
5.
5 classes, right? 5 houses, right? I mean, we agree with that. Okay, it's feasible, 5 houses. But then if somebody say, oh, the house numbers, the houses are numbered from 1 to 5. How many houses there? Still 5, right? But when you subtract 5 minus 1, that's 4. So what is the difference between this difference, 5 minus 1, which is 4, and when we see it here, there are 5 houses. So why when we subtract the numbers, we get only 4? Now 5 minus 1 give us 4, are 4 houses after the first class. These are the 4. Okay, that's the reasoning. Now, the actual definition of class width is actually, the difference between the length between lower class boundary to upper class boundary. That's the actual definition of class width. Okay, now to make it easy for you, the beginner in learning statistics, then those instructors redefine it to the difference between consecutive lower class limits. Okay, but the actual definition of class width is the length of interval from lower class boundary to the upper class boundary, as you will see later on below. Okay. Now let's go back. Oops, sorry. Let's do the tally. Okay, from 8 to 27, and then 28 to 47. Let me erase this so that I don't get confused with those marking. And then from 48 to 67, 68 to 87, 88 to 107. Okay, so let's see, from 8 to 27, how many are there? There are 6. 28 to 47, there are 11. 48 to 67, there are 17. 68 to 87, there are 13. 88 to that there are 6. Okay, now then I add them. 14, 17 plus 6, 76, 23 to 53. Is it the same to the number of? Yeah, yeah, it's the same. Okay, now that's our frequency distribution. Now let's copy that here. extend with lower class limit, upper class limits, lower class boundaries, upper class boundaries, and relative frequency. So these are the scores. The frequency, lower class limit, upper class limit, lower class boundary, upper class boundary, and relative frequency.
Professor, I have a question.
Uh-huh. Go ahead.
On your scores, the class, the second class, 28 to 47,
Uh-huh.
where are you getting the 47 from?
Oh, from the 27 plus 20. From here, you add the class width.
Right.
So
Oh,
you keep on adding the class width, adding the class width
so
like
it
that.
doesn't have to be an actual number of like, because I see it. There doesn't have to be a number 47 in the actual data.
You are correct. You are correct.
Okay.
Yeah. Okay. Now then let's copy that here. 8 to 27, 28 to 47, 48 to 67, 68 to 87, 88 to 107. And pull the line again here to close the gap. So the frequency was 6 and then 11, 17, 13, and then 6 add up to 53. And then this is 8, 28, 48, 68, 88. This one is 27, 47, 67, 87, 107. And this one here is 27.5. Am I okay?
Yes, so
Yes.
far, yeah.
Okay, thank you. 67.5, 67.5. 87.5, 87.5, then this will be 107.5, and this will be 7.5. This will be 6 over 53, 11 over 53. I say 53, I wrote 57. Oh, the 17 over 53, 13 over 53. 6 over 53. The total should be 53 over 53, which gives us 1. Okay, so far, any question? I hope not. Now, let's go back to Spring 18, the one that I already posted since 2 days ago, right? Let's go back here and we will continue with the next page, number 8. This is usually question number 8 in my test tends to be the longest question. Longest in the sense that it takes you a lot of number crunching. Okay, copy the frequency distribution in number 6 below and then extend to find the estimated mean, variance, and standard deviation. So let me construct the place first. This is the X, which is the score, and then F, and then later on I will do XI, FXI, XI squared, FXI squared. And the classes are 0 to 19, okay. 0 to 19, 20 to 39, 40 to 59, 60 to 79, 80 to 99. then the frequencies are 15, 17, 19, 14, 9. 15, 17, 19, 14, 9. Let me make sure I don't copy it wrong. Okay, and the total is 74. So far, so good.
Yes.
Yeah, all I do here is just copying. Now, next, the xi. The xi is the midpoint between lower class limit and upper class limit of that class. So here, the xi will be 0 plus 19 divided by 2, 9.5. Okay, now then use your calculator. What is fxi? Fxi is 292.5 xi squared. So 19.5 squared give us 380.25. Now then multiply that by the frequency 15.
I'm sorry, Professor, how did you get 292.5?
This one here, I
Yes.
multiply f times xi. F times xi.
I'm
What
not
did I
doing-
do? Hold on. No. You're right. Thank you. I happen to punch 15 times 19.5. Thank you. This is so wrong. That's all wrong. So 15 times 9.5 is 142.5. Thank you very much. This is fxi. And this is 5,703.75. Am I okay so far? Can I ask you to continue from here a bit? So you do the way I
So xi squared would be different then, right?
xi squared. Oh yeah, that's right.
90.25.
Yeah, it should be less than 100, huh? Should be less than 100. Yeah, it's 9.5. 9.5 squared is 90.25. 90.25 and then multiply by 15. That's 1,353.75. Am I good right now?
Yes, that's good.
5 times 25. Why I feel like something's still not right. Oh yeah, with okay with the 15. Yeah, so let me ask you to continue here. So and then keep in mind that when you add, you only add the one here, which I did. And then this is the second column, the sum of fxi that you need to add. And then the sum of fxi squared that you need to add. Do not add here. Do not add this. Don't add those. Okay.
Is it okay we write the X's on there on our test just for our own?
Not supposed to, but well, I don't mind. I don't
Okay,
mind.
it just
I
kind of
don't mind.
helps me to like remember not to calculate those.
Yeah, I actually don't mind, but in practice we don't do that. Yeah, okay. Yeah. Let me give you 1, 2, 3, 4, maybe 5 minutes to do this. Let me start. Do I get the same with yours so far?
Yeah, I have the same.
Yes.
Okay, good. Good news for me. And you too, of
And
course.
me, yeah.
Yeah, because if I make mistake somewhere, I will basically carry that mistake all the way. So see, one of the big problem when it comes to teaching stats and learning stats is I need to first train you to overcome your fear of big numbers. You know, like once you see a lot of numbers and big numbers, we tend to get scared. Of course, that's a normal reaction, especially you already have some trauma in the past with your math, right? But still, we need to overcome that. Okay, so even though this is a test, but I give you these all tests for you to practice. One of the reasons is to overcome your fear in big numbers. Okay, when we deal with stats, we deal with a lot of numbers. Okay, do I get the same number with yours, by the way, so far?
Yeah, that's what I have.
Okay,
Yes.
anybody else? Okay, so if
Same here.
any, yeah, if we have any mistake, at least 3 of us make the same mistake, which is very unlikely, actually, very unlikely. Statistically speaking, the chance somebody make mistake is like, let's say 1/2, but 3 people making the same mistake, it's actually 1/8, you know. Okay, so that's a sample. Okay, so when we need to find the mean here, it refers to sample mean. Sample mean will be 3,363 over 74. Now, usually I want you to make it into 5 decimal places, but here, because I say round the final answer to 3 decimal places, you can just make it into 3 decimal places. Okay. Now, if you round it to 4 or 5, that's okay. That's okay, but no less than 3. So if you round it to 3 decimal places, that's what it should look like. Okay, now then the variance is s squared. That's equals to, I hope you remember the formula already at this time. Can you tell me the first, second, third? The first number times the third number minus the second number squared over the sample size times 1 less than that. Okay. Now remember I said the first, second, third number, right? Now that mistake happens if you happen to add them here. So your first, second number will be different from mine. If you add this, let's say you have some numbers here, right? Then this will be your second number. This will be your third number. You see what I mean? Now to avoid that misunderstanding, then don't add them. I mean, you're not supposed to add them anyway. Okay. Now then I will compute that 74 times 202,418.5 minus 3,363 squared. That's 3,669,200 over 74 times 73 is 5,402. I get 679.230. That's the variance. Do you get the same number?
Yeah, but don't we have to square root it after?
After. So this, so far this is the variance. And then the standard deviation is the square root of that number. But I will use the number from my calculator though. Okay. That is square root of this number is 26.062. Okay. So, any problem here? No problem. Okay, let's finish this up. Number 9. From number 8, what is the interval within 2 standard deviations of the mean? So basically, we are trying to find an interval where this is the mean and the upper bound is twice standard deviation greater than the mean, and the lower bound is twice standard deviation less than the mean. Okay. Now, we call this lower bound or lower fence. This is the upper bound or upper fence. Now, the lower bound will be the X bar 45.446 minus twice standard deviation 2 times 26.062. The upper bound will be the mean 45.446 plus twice standard deviation 26.062. Let's use our calculator. I get negative 6.678. And I get 97.57. So the usual interval is from negative 6.678 up to 97.57. That's the usual interval. Now, then how about how to find the outliers? Outliers. Now, use this interval, compare that to our original data. Which data in this sample outside of this interval?
98 and 99.
98 and 99, right? 98 and 99.
Yeah.
Okay, then those are our outliers. Outliers are 98 and 99. Okay, now let's look back a little bit. Let's look back to this question here, to this data. Okay, one of the big issue from when we have a data is how do we know who is the one overperforming or we have a case of underperforming like this. Are these the one that outliers, they are performing poorly, or these people are the one overperforming? You know, now the thing is, if you ask me, I tend to say, oh, everybody less than 10 supposed to be not performing well, right? Okay, but using me as the judge to decide is biased because I'm the one writing the test. If you are not doing well, I will be the one yelling at you maybe, right? If my class is not doing well, then the dean may come to me. So what is the best way to judge if the scores are good or bad? And we want that method to be unbiased. So not depending on me, not depending on our pre-decided measure. Okay. Now the way we do it is by using this data, using this data set. You find the sample mean and sample standard deviation. Okay, so where's the mean coming from? From that data, from those students. Where's the standard deviation coming from? From that data, from those students. Okay, nothing from me. Okay, twice standard deviation away from the mean is a rules that is being followed basically by everybody doing statistic, and outside of those that twice standard deviation of the mean is considered outlier. So using the data itself that we got earlier, which Thomas himself didn't know before the test, right? After I finished grading, then I realized, oh, you know what? I have this data. How do I know if this is the one performing poorly or these are the one performing way too above average? Okay, maybe in our daily life we say this way: are these people actually breaking the curve from below, or these people the one breaking the curve from above? Okay, now it turns out that from our analysis earlier, we found out that these two people are the one outlier. Okay, you may say that Thomas, 98 and 97 are so close, and 97 from 92 are so far. Should we just count 97 in also? No, that's not how we do it though. Yeah, simply because they are outliers doesn't mean we ignore them. Okay, they are still our data. Okay, but compared to the rest of the class, you know, these are very far from the mean. And yes, if you look at the mean is actually quite low. Right, the mean is quite low. Okay, so is Thomas class underperforming? Yeah, in that situation, yes, underperforming, because we have two people overperforming, but the rest of the class actually not doing well. Okay, should we blame Thomas for that? Yeah, you can. Yeah, but of course, Thomas will blame the student first, right? But from my supervisor, maybe, then they will ask me, Thomas, what happened with this? You know, I always have a good answer for that, though, usually because of people with here, they don't have a good attendance, usually the case. Hey, with them, they have at least 5 different sets of test one they can study from. Okay, the fact that they don't do more than 30 is questionable. Like, what happened to you guys? You know, well, anyway, as an instructor, of course, I try my best to provide to you the tool that you need, but unfortunately, not every student actually listen. Not every student have the chance to actually study. If you take a look on your quiz, of course, you can only see your grade, right? You can only see your grade. But if you take a look on your quiz, I cannot show you, by the way, I cannot show you. But the average for your quiz of 22 students turning the quiz, the average is 5.9. The average is 5.9. Somebody gets 0.5. Of course, I have some people get 10s. Somebody get 2, somebody get 3 of these 22 people. Now, to be honest with you, if you get less than 3 or less than 3, I say it in your, I write a note on your quiz that I want to see you during my office hour. Let me show you what I meant.
I mean, to be honest, the people that are getting those low grades, I mean, look how many people are actually here getting ready for the test, you know?
I more or less agree with you, but at the same time, I have students not showing up but still doing okay. You see what I mean?
Yeah.
They're still doing okay even though they don't show up. So it's about like you managing yourself to study, you know, making you don't need to show up to class at the same time with me. By the way, I want to thank Sonia to give me her permission to use her solution as my solution. Okay, there are some people getting perfect, but among those people getting perfect, I think Sonia's solution is the one very neat. It's like, even if I write the solution myself, I don't think I can write, oops, why did I post a wrong one? No, not supposed. Sorry, this is a wrong solution. This is from SMC. What the heck did I do? Not that one. Sorry. I need to change that. But yeah, Sonia is actually the one who can write even better than if I'm the one writing it. So thank you, Sonia. Yeah,
You're
I also
welcome.
thank you. I also asked the question if I can use her name, and then she said, Thomas, you can use my name. Yeah, but I'm not saying that she's the only person getting 10. Okay, there are 3 or 4 people actually getting 10. There are 3 or 4 people getting 10, but she wrote it so nicely. Let me show you. It's like very neat. Now, I don't expect you to give me this kind of like nice handwriting in your tests. Yeah. Okay. Especially in your tests, but make it reasonable. Okay, make it reasonable, and those reasonable outcome can only show up from enough practice. Okay, enough practice. Okay, now that's for this quiz one. Now, for you can look at your submission. I usually write some notes when I give it back to you. So you go to your submission again, and then I don't know where you can find it here, but there should be a note somewhere here. If I write you a note. Okay, if you get 3 or less than 3, I may say see me during my office hour or after class. I want to find out what's not right. You see what I mean? I want to find out what is not right. I want to find out what's wrong and what we can do to make it better. Why I cannot change it there? Okay. Now, using this same information. Let's look at that spring 16. Okay, spring 16, the one we did earlier, right? This is the frequency distribution, and that's a population, by the way. That's a population. So let me ask you to work on this problem. Or you know what? Let me just do it. Let me just do it. It's already 9 o'clock. Let me just do it.
Professor, are you going to post this solution?
Yes, I will. I will post it back to our discussion board. So if you go to discussion board later on, you will see that I posted there. Okay. Yeah. Before we're done, I will show you where I posted. So it's the scores, and then the function, and then the midpoint, and then f times xi squared fxi squared. Now, if you happen to know how to use Excel and you want to use that during your test, go ahead. Okay, if you want to use your computer. Actually, if you want to stay a bit longer today, I think I should finish before 9:40. I can show you how to use your calculator to plug in these numbers. So this is 8. The thing is, like, if you use calculator, you may end up spending more time typing numbers in. That could be the case. The frequencies are 6, 11, 17. 6, 11, 17, 13, and 6. 13 and 6. When I add, that's 53. 35 divided 8 plus 27 is 35 divided by 2 is 17.5. Let me slow down here. I hope you follow me so far. Let me know if you need more time to copy this down. I will post it later on, but I would like you to follow me also. Can you help me to find the midpoint of the second class?
37.5.
Great, 37.5. Now I want to tell you some little secret, which not supposed to be a secret actually. The way that we construct this frequency distribution make it so convenient for us, even if we need to do it by hand. Notice that the class width is what?
20.
Okay, so 20 here, and the way we did it, we also have 20 here, right?
Yeah.
So then what happened with your midpoints will also have the same distance. You add 20, you add 20, you add 20.
And that rule obviously that rule applies for like any solution, right?
Repeat again.
That rule would apply for any solution, right?
Any frequency distribution that you construct the same way. If you construct that the same way, it should be the same, like that. Okay, so what happened is this: if you don't attend this class, or if you don't listen to this recording, then the way you compute this, you add this 2 divided by 2. The way you compute this, you add this 2 divided by 2. Even though you get the same answer, but it takes you longer time. And somehow, if you know a little bit more shortcut, it builds your confidence a bit higher. Don't you think so? All right. Okay. Yeah. Now, so let me go on. 6 times 17.5. That's 105. 17.5 squared is 306.25. Oh, I need more space later on there. Times 6 will be 1,837.5. Let me move the 1 closer to 8. 37.5 times 11 is 412.5. 37.5 squared is 1,406.25 multiplied by 11. 15,468.75. 17 times 57.5. 977.5. 57.5 squared is 3,306.25 multiplied by 17. 56206.25. 13 times 77.5. That's 1,007.5. 77 squared is 6,006.25 multiplied by 13. 78,081.25. It's 585. 97.5 squared is 9,506.25 multiplied by 6. 57,037.5. Okay, now I add the to get the second number. I get 3,087.5. Okay. Please check my work also. Actually, I will show you later on how I check my work. let me show you how I will check my work. Do you have your TI 83 or 84 with you?
Yeah.
Okay, now bring it up. Together with me, we do this. What I will do is this. I will plug this column here, the XI column, into calculator and frequency column into calculator also. Okay, now how do I do that? I go to stat. Okay, and then edit. Now, oh, I have some numbers here. L1, L2, L3. Let me clean them up first. Now, check yours. If your L1, L2, L3 already occupied, then you need to clean them up. How to clean it up? You go back to stats and choose option number 4, clear list. Choose option number 4, clear list. I will clear list number 1 and 2 and 3. Now, L1, L2, L3 are here. I wonder if you can see it. On my calculator, my calculator on computer is the blue part above 1. On your calculator should be yellow. It says L1, L2, L3. Do you see that?
Yes.
Okay, now then I want to clear list 1, 2, 3, but I need to get the blue part first, going to second L1, comma, second L2, comma, second L3. Now then when you press enter, it will clear all these 3 columns. And I will go back, stats, edit. You see it's clean already, right?
Yeah.
Now then my list 1, my L1, I will enter the input from XI. So that's 17.5, enter. And then 37.5, enter. 57.5, enter. 77.5, enter. 97.5, enter. Are you following me?
Yeah.
Okay, everybody?
Yes.
Okay, now let's go on. So then I move to the second column. My L2 will be my frequency column. 6, enter. 11, enter. 17, enter. 13, enter. 6, enter. So far I only input data. My L1, I follow the scores, right? So I put it on the left-hand side of frequency instead. L2 is the frequency. Now, I will move the cursor to L3. You see where my cursor right now? Right below L3, right? Now, move it up. What we will do here is we will tell them to multiply the cells from L1 and L2. Now, the way we do it, I will plug in L1, L1. You see that here? My cursor is here, right? Okay, that's my cursor. Okay, but what I tell them to do is, okay, for L3, column 3, multiply L1 by L2. Boom. You see that? Check. Is it okay? So my numbers are okay, so. Now then let's move the cursor to the right. L4 will be our L1, the square of xi, right? So you move the cursor up again. You take L1 and then square it. Boom. Now the problem is they do rounding. They do rounding. But you know, oh, they rounded to 3 because it's supposed to be 0.25, right? Okay, now then you go to L5, you will multiply the frequency column, which is L2, times L4. Again, unfortunately, they do rounding. They only give us 5 digits. They do rounding, but at least you see that the first one is correct. The second one, we have 15,468.75, which if we round to the nearest unit, it will be 469, right? Do you see that? Okay, so you cannot really use this calculator to work it out, but you can use that to confirm.
Thomas, on my
Yes.
calculator,
Mhm.
if you like scroll down to like go to different numbers, it does show you the decimal. Like if you were to like go stay
Oh,
on,
yeah.
Yeah.
Yeah, thank you.
you're welcome.
Yeah. So yeah, when we scroll it down, okay. Now then, if you want to see the sum, you go to stats, okay, and then calculate one var stat, and you get list number 3 is FXI, frequency list, ignore that. So you get the sum. This is the sum. This is the sum. Forget everything else. You just need the sum, right? This is the sum. Now then, if you want to find the sum for the last column, which is list 5, this is the sum. Okay. Now I'm teaching you this as an alternative if you don't want to get too busy with number crunching. I mean, I know some students doing this during their test, and they feel like they're cheating. And I actually walked to her saying, no, I don't consider that cheating. Don't worry about it. So, oh, you saw what I did? I say, yeah, I saw it. I'm happy that you know it. Yeah, so it's okay. It's okay. But all these numbers does not help us finding. We only get the most difficult one. In this case, I use that to confirm. I use that to confirm now. But then we still need to compute them, compute the mean, right? The population mean is 3087.5 over 53. Then I will use my calculator, and I only need to round it to 3 decimal places as what the question says here. It gives me 58.254, 25477, so it should be 5 here. Yeah, if I round to 3 decimal places. And the variance is the first number times the third number minus the second number squared over the first number squared, because this is population. I get 6,824,800 over what is 53 squared. 2809 equals to 2429.619. That's the variance. Therefore, the standard deviation will be the square root of that number, which is equal to, let me put it here. No way, something not right here. Okay, let me write it down first. This is 49.291. I believe I make a mistake. Let me count it again. Yeah, I make a mistake here. I miscompute this part.
Yeah, that's what I was gonna say. I got a different number then.
Yeah. Yeah, I get 1,524,800. Yeah, I must have punched something wrong earlier. And then divide it by 2,809. That's 542.8266. So I round it to 7. The square root of that is 23.299. Supposed to be 86, but when we round becomes 9. Okay, that's the standard deviation. So what is the interval within twice standard deviations of the mean? So the lower bound or lower fence equals to the mean minus twice the standard deviation. So 58.255 minus 2 times 23.299. That is 11.657. And the upper fence or upper bound I get 104.853. So the usual interval will be 11.657 to 104.853. Okay, that's the usual interval. Now, the judgment day. What's the outlier? How do we know who is the one overperform or underperform? The interval is from 11 something to 104 something. So is this 104 outlier?
No.
No, it's not. So what is the outlier?
8.
Is there other number?
No, just 8.
Just 8. Okay, so you see that when we try to make decision who is the one overperform, underperform, using this technique, we do not use my instructors or your students' point of view, but we use the data set, because different students have different experience when it comes to math. Like some people will be happy to get 70s, some people only happy to get 90s, right? And some people getting these scores here happy enough to get something because it means he or she actually took the test, and nobody can say that person is actually somewhere else. You see what I mean? Okay, so different people have different experience. We have our own bias to say this grade is good or this grade is bad, right? But then if we need to do it scientifically, objectively, use the data against the data, then we can say, oh, you know what? It's not the 104 for performing, it's the 8 that the one underperforming. You know, this 8 is actually separated by from the group. Thomas, is it possible that you have outlier in below and outlier above? Yes, it's possible. Yes, it's possible. Okay, it's not that common. It's not that common, but it is possible. It is also possible you don't have any outlier at all. It's also possible. Okay. By the way, Have you ever heard about if the instructor curve the grade? Okay. When I did my undergrad back in Indonesia, all the classes there, we knew it since orientation that all the classes are actually graded. The letter grade you get is by curve. The thing is, when they say by curve, it's not like curve to make you happy. No, they don't do it that way. That's not what they meant. When they say curve, they do it this way. This is what it means. So from the student's performance, all the data, okay, the teacher will find what is the class mean and what is the class standard deviation. Okay, now at the end of the semester, when the teacher try to give you the letter grade, then the standard is this A. If you look at our college catalog, which is also my university college catalog, okay, A is defined to be what? If somebody got an A, what does it mean? Have you ever read your catalog? Somebody say something.
A is a good grade. What is it, 90 to 100 or
No,
89?
No, that's not what
No?
it says. No. A is excellent. Now, then it depends on your teacher to determine what is excellent, right? B is good. C is average. D is below average. And F is fail. Okay. Now the way I make it in my class, 90 is your excellent, right? Your good will be 79. Your average is 68 or above, right? Okay. But back in Indonesia, when they say excellent, the definition of excellent is not determined by the instructor, but determined by the data. So excellent, you will get an A if your score is greater or equals to 1.5 standard deviation above the mean. So let's say the class average is 50. Okay, that's the class average, and then the standard deviation is 10. Okay, so if your average, if that's the class average, if your average is more than 50 plus 1.5 times 10, that's 65, right? Okay, so if your class, your average, all your tests and quizzes put together turns out to be 67, you get that A. Oh, Thomas, that's really nice. Oh, not too fast, not too fast, not too fast, not too fast. Okay. For B, if your score is greater or equals to 0.5 standard deviation above the mean. You get C if you get at least negative 0.5 standard deviation below the mean. So if you look at the number line, let's say this is the mean. Okay, the cutoff is the mean plus 1.5 standard deviation, that's for A. The mean plus 0.5 standard deviation, that's for the B. The mean minus 0.5 standard deviation, that's for C. So this is the A, this is the B, this is the C. Like that. The D is the mean minus 1.5 standard deviation below the minus 1.5 standard deviation. That's our ABC. Now, we may say, oh, Thomas, so if we get 60, if we get 67, we got an A. Well, it depends on the mean of your class and the standard deviation. Okay. Then what happened back then, our instructor actually allowed us to cheat from each other. That's okay, Thomas. That's okay, because what happened is this. If everybody get the same grade, everybody get 90. Let's say everybody get 90. Can you tell me what is the average? If everybody get 90, the average will be 90, right? What is the standard deviation? 0. So even though everybody get 90, you are exactly the mean. So everybody will get a C. So go ahead, cheat. That's with my teacher. That's what I mean with our teacher in Indonesia. So there is no fear of the teacher writing the test too easy or too hard, because at the end, he will look at the curve. If my test is too hard, then the average is supposed to be low. But students who are better will do slightly better than the bad average. Okay. Now, I once got an A in my, I remember that's a PDF, partial differential equation class. I forgot what the grade precisely, but let's make it this way. Like my teacher gave us the test and then he just left. We would work on the test. And let's say everybody got 30, except Thomas get 32. Let's say there are 20 students in that class get 30, and then one person get 32. Can you imagine this? What is his average? What is the average, class average?
31.
No, it's not 31. The total is 20 times 30 plus 1 times 32 over 21. Yeah, if you do the frequency distribution, the ones getting 30, there are 20 of them, right? The one getting 32, 1%, right? So the mean will be 600 plus 32 divided by 21. You see that? 632 divided by 21 is 30.095. So all of the sudden, everybody who get 30 actually get below average, right? Do you see that? Okay, we need to compute the standard deviation though. Okay, but from here we see that for sure these 20 people will not get an A, but will not fail either. Okay, these people who get 30, they are in this interval, so they are safe. They get a C. Okay, the unfortunate thing is Thomas get 32. And if you compute the standard deviation is like 0 point something, and 32 is more than twice standard deviation away from the mean. So all of a sudden, these people got C's and only one person get an A in that class. See, now in America, if you get 32, you still fail the class, right? At least in our class, right? If you get 32, you fail the class. There, and before everybody failed the class, I believe the whole class already complained to the dean, right? To the department chair, to the dean. But there, when you try to complain, the dean will say, well, that's not the end of the game yet. Okay, he write the same test for everyone, so it is fair. And the way he gives you passing, not passing, it is compared to how the class actually perform on average. Right? So when they say you are average, you're excellent compared to your friend. Okay, not to compare to what the teacher think. You know, doesn't matter what the teacher think. Now, it saved me for an A, but there was one time everybody's doing very well. Let's say everybody get 92 and Thomas get 93. That's so, I'm sorry, that's so fucked up. You know, I just happen to have 1 point more in the final average. And what happened then, all of a sudden, everybody get more than half standard deviation less than the mean. So the whole class get D's and F. And I got the A. Because of my extra correct work, I make the whole class actually fail. Now, the thing is, my teacher say, Thomas, even if you get 92.5 and the rest of the class get 92, you will get B's and they will get C's. You know, so like for every A that you get, somebody need to sacrifice the F for F or D or C, like that. You know, it's just like the number gets so wrong. So what happened with that class? Everybody in my class except me need to repeat that class because of this kind of game. That's why I say you want to cheat, fine. I mean, but just make sure you don't have someone actually suddenly get a better grade just a little bit. You know, of course, my class hate me so much because of that. You know, but I get the same issue also before. Okay, as I get the same issue, I end up with a B because somebody get an A. You know, I just 1 point more and somebody is like 3 points more. It's like, oh shoot, I end up with a B and that person end up with an A. You know, we expect that all of us getting C's. You know, yeah. Well, that's what happened. Well, anyway, let me stop it here. This part's not supposed to be recorded. Why we talk about this? Because we use this to judge the data using the data itself. You see the technique, right? I use my undergraduate grading system to show you how the teacher actually don't really need to worry about if the test is too hard or too easy. Now, of course, here with me, I don't have that mindset, okay? Because the way we set the A is 90 or above, right? And it is possible everybody get an A. There, it is impossible everybody get an A. That's impossible. That's why it is far more difficult in Indonesia for somebody have a cumulative GPA 4.0. When I came to America, I heard so many people get 4.0. I was just like, wow, these people must be so smart. Until when I look at the way they do the grading, I say, nah, all you need to do is the student actually push the teacher to give easy questions. But then what happened later on when you go to work, that's another story, you know. This is where I will stop. It's 9:34, 9:35. Stop recording.